Well, Larry, you know that today is our first year of meeting anniversary?
Oh, really?
Yeah, so I bring a surprise for you.
Oh, that's great. I want to see.
Well, I've got no money to buy you a real cake,
Okay.
but, well, there's still a candle for you to make a wish.
Oh, that's great. So I will close my eyes and make a wish. I hope that I'll get 9 A's for SPM and it's still lighted. I thought I had already blown it out.
Well, maybe it wants to give you another wish.
Okay, I'll try it again. I wish that I can get it's you who lighted up the candle. But how do you do it?
Well, actually, when the candle is lighted, the heat of the flame is vaporized in the candle wax.
Oh.
So when you blow off the candle, the vaporized wax is still remains briefly in the air. When there's a heat source nearby, you can actually ignite the vapor wax and use that reaction to relight the wick of the candles. Again.
Cool. So, Lim, do you know that the flame has no shadow?
Oh, really?
Uh-huh.
Let me have a try. Wow. The flame really has no shadow.
Uh-huh.
Very. Can you tell me why the flame has no shadow?
Okay, hold on. Let me turn on my lights. Okay, so I'll tell you what's really happening. So when an object is illuminated by light, it creates a shadow. So a shadow is a darker area, it's a more darker area than its surrounding because something is blocking the light partially or fully from that area. So in this case, flame has no shadow because it is the source of light. So when it is a source of light, it's not a concrete object, hence it is just glowing air. Therefore, candle cannot produce shadow as there is no way this flame can block light as it is a source of light itself. Hence, no shadow will be formed by flame.
Oh, I see. That's amazing. But, Barry, I found some orange peels here. What's the use of these orange peels?
Let me think for a second. Why don't you try bending the orange peel and there will be this oily substance going out of the orange peel and try to do it closer towards flame. Be careful, it is really flammable sometimes. Okay, count of 1, 2, and 3.
Wow, it really do produce fire though. Well, Barry, how can this orange peel produce fire?
Okay, let me tell you. So when you bend this orange peel, there's this oily substance sprayed out of the orange peel. So when you bend it, the skin will be stretched and the oily substance will be sprayed out of the orange peel. And this oily substance are hydrocarbons, a little bit like fuel, so it is highly flammable. So when you bend the orange peel, the oily substance will be sprayed out and it will mix with oxygen in the air and will produce a flame which looks like a fireball.
Oh, wow, okay, I see. But actually, Larry, I still got another surprise for you.
A surprise?
Yes.
Okay,
Let's
come
go
on.
and check it out. So, Larry, before this surprise is coming out, I want you to close your eyes for a while before I make a surprise for you.
Okay.
Alright, so now I want you to open your eyes and use this lighter to light up this soapy water.
Are you sure? Water and fire are incompatible. There's no way it's gonna light up.
Well, Larry, just give it a try.
Wow, it is lighting up. But you and your good deeds, is this what you call a surprise?
Well, I'm so sorry, Mel, but actually I just want to show you that I can produce an even huge fireball with using an orange film.
Ah, that's fine. Okay, tell me what's happening.
Well, this is actually not an ordinary soapy water, but I've actually added some butane gas into this soapy water by putting this nozzle under the surface of the soapy water and giving a few squeezes. Since the butane gases is lighter than the air, so the bubble will grow and rises more as you are infusing more butane gas into the soapy water. But the bubbles are extremely flammable, so that when you light up the soapy water, it will form a really huge fireball.
And with that, we end our science show today about fire!